Hi guys, today we are going to discuss about IPSLA. What is IPSLA? The IPSLA, if you see the Internet Protocol Service Level Agreement, SLA means Service Level Agreement. Okay, in IP we are going to configure a service level agreement to monitor a network performance feature in the Cisco IOS that enables an IT professional to collect information about network performance in real time. Let me type it here. IPSLA, Internet Protocol Service Level Agreement. IPSLA is a network performance monitoring feature of the Cisco iOS that enables an IT professional to collect information about network performance in real time. By using this, we can monitor our routers link connected link performance. Okay, based on that we can take a decision, okay, which path it has to go. All those things we can do it. Okay, usually, okay, if IPSLA is configured, okay, it will do the monitoring of IPSLA, and then we will get a log SNNP logs into the monitoring tool. Okay, then we will be understand what is the performance of that particular link, like a response time, latency, jitter, packet loss, all those things we can monitor over the IPSLA. That is a very much use cases of IPSLA where we can use it. Okay, now today we are going to discuss about IPSLA, how we are going to use it. There are the response time, latency, jitter, and then voice scoring quality. Even we can monitor the voice qualities, okay, all those things, how the packet latency, everything, and then connectivity usually, okay, what how the connectivity is up or down, all those things we can over that IPSLA we can monitor. Okay, these are the parameters we can. Let me see what is the difference between latency and jitter. See the latency, it is the what is the delay in the network, okay, to communication. Okay, if we can take from here to reach there, what is the time taken, okay, what is the delay between that, that is a latency. If you take a jitter, okay, jitter also almost equivalent to latency. Okay, but only thing is how much interval is ticking. Okay, packet to packet, what is the difference. Okay, like latency is how much delay is happening. Okay, each and every packet, how much delay is happening. Okay, what is the difference? Is there any frequency mismatch? Is there all those things? Jitter will monitor it. Okay, when we are going with a more intensive traffic like a voice, all those communication, we should have monitor the jitter as well. Okay, that we will see now. Okay, while doing the lab latency. Network latency is the delay in network communication. Mainly for the network performance monitoring feature which is there in Cisco iOS by default. Okay, by using that we can do the mm, very effective network performance monitoring in real time, as well as we can based on that IPSLA we can track it some of the features, and then we can take a decision of how we need to do the routing. Many things we can use it. Okay, many purpose we can use it. Now that we are going to discuss in the lab. Okay, before that, let us have a discussion. Discuss about what is the latency, what is jitter. See, latency is the time taken for a data to travel from one source to destination. If jitter means okay, the variation in the latency over time. It's a measurement of both the latency and jitter in milliseconds. Processing delay, queuing delay, transmission delay, propagation delay, etc. All those comes under the latency. The jitter reflects inconsistency in the latency due to network fluctuation. For example, for one traffic is a 1 minute, 1 millisecond, okay, another is a 2 millisecond, at a suddenly 10 milliseconds, okay, there will be fluctuation, right? Okay, for those things and all, jitter will get monitored. Affects overall speed and responsiveness of the network connection. In jitter, okay, impacts the consistency and stability of data and transmission. The nature of the latency is the generally a static value. Jitter is a dynamic and can fluctuate over time. For example, 50 ms latency means it takes a 50 milliseconds for a data to travel from source to destination. Jitter of 50 ms means latency varies by up to 5 millisecond over the time. Okay, let us do in the lab. Okay, let us before that let us discuss what is the benefit of IPSLA. The IPSLA monitoring, it provides a service level agreement for monitoring, measurement, and verification. And then it is a network performance monitoring, measures the jitter, latency, packet loss in the network. Provides the continuous, reliable, predictable measurement. See, if we once we enable, okay, it will be keep on doing it. Okay, how you configured based on that interval, it will be keep on checking it. Okay, whether it is any down or what, all those things. So even we cannot check manually, right? Okay, it will if anything goes wrong in that value, immediately it will pop up. Okay, it will send the alert to the monitoring tool. Okay, it will be sending to the SNNP trap logs, and then SNNP trap logs will be get captured in the our monitoring tool. Our monitoring tool will send the alert to the respective engineers. Okay, the engineers will have to take action on that. Okay, it's a very useful tool. Okay, lively. Okay, we'll be using this kind of IPSLA monitoring in most of the cases. Even if you want to do the QoS, all those things also we can do the monitoring with the IPSLA. See, it's provided edge to edge availability monitoring. When real network, okay, it's a very sensible network, we need to get monitor, we have to get enable IPSLA. Okay, it is a troubleshooting immediately. It identifies the problem. For example, if you have the service provider, okay, in or the service provider, okay, for reaching the service provider, peer IP, okay, one time you're getting 5 millisecond, another time you're getting 10 millisecond. Suddenly it is going to 100 millisecond. Okay, all those things will get captured. It is abnormality, right? Okay, it is a huge fluctuation is there in the latency. Okay, that will get it capture in the jitter. Okay, it will get an alert for us. Even latency, okay, if one continuous streaming is happening, one drop is there, immediately we will get an alert. With that, it will be very helpful for us in live monitoring when we are going in. Even when voice traffic is passing, okay, the link should be very handled very sensitivity. Otherwise, this voice traffic will get dropped. Okay, we'll get a noise. Okay, we'll get a one side audio, all those things. For that, we have to get monitor the link very actively. For that purpose, the IPSLA will be configured in most of the even where the voice traffic is passing. There IPSLA will be configured. Okay, what is the jitter, all those things, latency, all those things. We'll be configuring it. Let us do the lab now for this. Let me start a lab. Let me turn on my EVE. iOS. Okay, adding one more router. Now router 4. Router 3, router 4. Now we have to connect the device in between. Let me connect here to here. Okay, and then connect here to here, here to here. Consider ESP2. This is ISP2. Duplicate. This is the ISP1. ISP1, ISP2. Now we have two I. This is my source router, source where all are sitting. Okay, and then this is my edge router. Here two ISP we have. In this two ISP we have IPs like 3.3.3.3 and then 33.33.33.33. These are the two destinations of the consider. Same here to there. Okay, I have to use the two ISP. This ISP1 is my primary, ISP2 is my secondary. Now I have two ISP. This is my primary path. I can reach the 3.3.3. In secondary path also I can reach the 3.3. Now I am going to do the IPSL. Before that, here 192, 168, 12.10/24, which is my network here. Dot one will be IP assigned here in this interface. Dot two will be assigned in this interface. Now let us decide everything what we are going to assign everything. Now here 192, 168, 23.0/24. This is the network is used here. Here to IP 2. Dot 3 will be used here. Now in this network here 192, 168, 24.0/24 will be used here in this network. Dot 2 will be used here, and then dot 3 will be used here. Now, okay, now there is a router where I'm going to initiate a router. Then it will come to this is my core router. You can consider as a core router. Core device. Consider this is my core device. This is my edge router. This is my edge router. These two are my ISP routers. Let me power on all the devices. If you go here, more action, start all the nodes. It will power on all the devices. So all the devices are getting started. Now we will start doing the configuration. Router 1, router 2, router 3, router 4. I have opened all my routers. We will start configuring one by one router now. It will take few minutes to get start. Let us wait. Now by this time my router should be powered on. Okay, now it's on. Let all the routers get power on. Meanwhile, let these routers get on. We will prepare a configuration offline. Let us prepare a configuration in offline. Let me open a notepad. We'll start preparing. Yeah. Let me open notepad plus plus. It will be like meanwhile we'll give no here. Okay, still it's loading. Now router 1 configuration which we are going to prepare. Config T interface GI. Let me minimize this. First is GI 0/0 IP address 192.168.12.1/24.255.255.255.0. No shut. This is interface which is connected to my router 2. Now basic configuration router 2 config T interface GI 0/1 IP address 192.168.23.2 255.255.255.0. Enter. No shut. Another interface int GI 0/2 IP address 192.168.23. Sorry, 24.2 255.255.255.0. No shut. Now we have configured second router to now configure router 3. Router 3 is ISP1. ISP1. Here interface GI 0/0 IP address 192.168.23.3 255.255.255.0. No shut. Another interface GI 0/ router 3 is completed. Now to router 4 we need to configure. Let me configure router 4. This is ISP2. This also configuration remains same, only IP need to get changed. Instead of 2324 will come, here .4 will come. That is a major interface configuration. Now we have to configure a loopback IP address as well. Here I'll change the IP address. .4. Now loopback address, let me interface loopback 3 IP address 3.3.3.3 interface loopback address 33 IP address 33.33.33.33. These are the two loopback which we'll use it. Here 255.255.255.255. Same I'll give here as well. 255.255.255.255. The both side will use the both ISP1 and 2 will use the same loopback address. Now let us do the configuration. It is taking time. Let me give no to everywhere. After that, it will take few seconds to get come up. Okay. Outer one is doing all pre-checks. Let us do the configuration once it comes up. Enable config t host name router 1. Now already we have ready our configuration ready. Okay, we will copy paste from here. Router 1 configuration is done. W or right mem. Now let me go to the router 2 configuration. Enable config t host name router 2. Now in router 2, what is the basic? We have to configure. Okay, we have to configure one more configuration also. Interface GI0/0 IP address 192.168.12.2 255.255.255.0 no shut. Actually, three interfaces are used in the router 2. Let me ping from here to my core router. Core router is 192.168.12.1. Yes, it's pinging. I have connectivity now between my core router and my edge router. This interface configured. Now I'm going to configure R3 and loopback address. Let me copy this and paste it in router 3. Enable config t host name router 3. Okay, now I have configured interfaces right mem. Let me ping my edge router. Edge router, I'm pinging. Yes, it started pinging. Now let me configure a router 4. Enable config t host name router 4. Router 4 configuration also I'm pasting. Yes, done. Done. Sorry. Let me ping my router 2 from R4 ISP2, which is my ISP router 2 to I'm pinging my edge router. Ping this ping everything. We should ensure our connectivity is up. For that is the purpose we are pinging here. Now all the devices we have done the basic configuration. Now in this router 1, let me configure my own loopback address. Loopback 1 IP address 1 dot 1 dot 1 dot 1 255 dot 255 dot 255 dot 255. Okay, now we have configured loopback. Now let me add a static route here, my core router to my edge router. I'm going to configure default route IP route 0.0.0.0 0.0.0.0 to my next stop is 192.168.12.2. Here I have configured static route. Now in R2 is my core router, my edge router, sorry, it's my edge router. I have connectivity to my ISP1 and ISP2. My primary path is my ISP1, which is my primary path is my ISP1. Now I'm configuring one static route IP route 0 dot sorry 3 dot 3 dot 3 dot 3 255 dot 255 dot 255 dot 255. Next stop is 23.3. These are my primary path I am configuring. First, I will configure the static route here. Then I will demonstrate where I am going to use the IPSLA with the tracking. Let us take a reachability IP route 33.33.33.33 255.255.255. Both I am making this as a primary path. Now let me configure a secondary path as well. Secondary is my 24.4. For this also 24.4. Okay, I have to give some metric. I forgot that. Let me give that. A little bit higher metric I am giving. 20. Sorry, 10. Now if I give the show IP route, primary is this. Primary is that only showing now. Okay, let me add here in R3. Let me add reverse route for 1. Config T IP route 1.1.1.1 255.255.255.255 exit interfaces dot 2. I have added reverse route here. Now R3 R4 I am not going to do any changes. In edge router we will do all changes with respect to the IPSLA and all. Here too for IP route 1.1.1.1 255.255.255.255, and then my next hop is to reach 1.1 network is 192.168.24.2. So everything is configured. Now let me ping 3.3.3.3 with a source loopback of 1. Okay, what is the problem here? In router 2 I have not done the routing for 1.1.1. Let me add the route for 1.1.1. Ping, sorry, IP route 1.1.1.1 255.255.255.255, which is 12.1. Now it will ping. Yes, it's pinging now. If you do the trace also, it will completely go via this path. Router 1 to router 2, router 2 to router 3. Secondary path is router 1 to router 2, router 2 to router 4. I mean ISP2. What we will do now, for time being, we will shut this link. Let me shut the link of router 3. Let me shut the link GI 0/3. 0. Let me shut the link. Config interface GI 0/0 shut. Already we have configured the floating route. Okay, definitely it is going to ping via secondary ISP. It will change the traffic. You see earlier trails. If you see here, going to the my core router, edge router, from edge router to service provider router. Now let me ping again. It's not pinging. Let me see what is happened here. Show IP route. Still why it is taking this route. See now, this will happen in real time. That's what I want to show you guys. Now I have shut down this side interface, but opposite side is not went down. Because of that, still the traffic is trying to go in my primary path. See, this interface is still showing up. I am having ARP. Still ARP is not cleared. ARP is there still. So there still I am landing this as a route. I am getting a drop here. Okay, my floating route is not working here. Why? Because my edge router thinks still my ISP1 is up. Okay, why I have to look for a ISP2? Okay, I'm learning ARP. Okay, I have static routing. If you see here in my router 2, show IP route, still that interface is not went down. Okay, still it is showing as a active. Now, even service provider went down. I have active standby. Even I have configured the floating route. If primary files, okay, it has to go secondary route. Because of this, okay, most of the time, if you look at the service provider, okay, the link will go down, but interface will be remains up. Okay, even that ARP cache will be there. Till that ARP cache get clear, it will to reach that particular path only. Let me do one thing. Let me clear the ARP. Clear or catch IP address. I'll give this particular IP address. Let me clear it. Still ARP is there. Clear or interface. Now I have cleared the ARP. Now let me check show IP route. Still this route is only getting installed. Since it is a static route, there is no mechanism to look it. Let me configure now IPSLA. IPSLA will solve this problem easily. Config T IPSLA. Okay, we have to give some number. I'm giving it 10. Now we have to configure these are the parameters we can monitor it. Okay, let me now ICMP echo. For us, ping is sufficient. Destination IP address is this IP address. Source interface. Source interface is not required. Okay, anyhow, it will go here by default. Frequency 5 seconds, every 5 seconds. Threshold, I'm configuring a threshold. Okay, how much threshold it has to wait? Okay, every 5 milliseconds. Okay, now IPSLA is configured. Let us verify PSLA 10. IPSLA summary. Why? Show IPSLA summary. We have configured IPSLA now. When it has to start, that also we have to give command config t IPSLA schedule. What is I? It is our number is 10. Start time. So we will give the forever. Life forever, always like start time now. Immediately it has to get start. Let's see the show IP SLA. SLA statistics. It is a failure now. Now let me configure track. Track object, which object? IPSLA 10 IPSLA 10. Okay, track 10 is a number, whatever we can give it. Okay, now here I'm going to track a IPSLA 10, whatever is going to configure, whatever it's we configured. Show run route. Okay, now this is a primary ISP only, still it's taking. Okay, because that interface not went down, all those. Okay, now this is some misconfigured route. Let me delete that.
Actually, we
Oh,
need to
it's not
call the
misconfigured.
track in interface, right?
Yes, Altaful. Hello.
Yeah, actually, we need to call that track in the interface also, right? Or
I'm going to do that. I'm going to do that. Be patient.
okay, okay.
Okay, let me call the track. Now I'm going to remove the static route which is configured. I'm sorry, I'm in router 3. I have supposed to do it in router 2. Config T. I'm going to remove this route now, which is my primary path route now. I'm going to remove. Instead of that, I am going to do the track with going to configure the track. IP route, the same command, only difference is I'll tell you. track 10. Once my track is up, and that the track IPSL is up, then only it will choose this path. In case my IPSL is down, it will look for the secondary path. Let me configure here this as well. Track 10. Now show track. Okay, my track is down. Show IP route. See here now, since my track is down, it has taken this path. My track is down, it has taken this path. Now let me ping here from my primary router. Let me do the ping. Now it will ping. Now it started ping. Now what I will do it, which I have shut down in my router 3. Let me turn it on. I have shut down here, right? Let me turn it on. GI 0/0. No shut. Now my primary ISP link will come up. Okay, what will happen? Let's see. Earlier the track was showing down, right? Show. Oh, okay. Automatically the track came up. See here, we could able to see the logs. Okay, the similar logs. Okay, whenever the track is going down, now if you see the show IP route, it will show my primary path. Again, let me do the experiment for you guys. Let me shut down my ISP1 config T interface shut. Now again immediately in router 2 we'll get a show track. So immediately within a fraction of seconds, okay, it will 2 or 3 seconds, it went down. Track also went down, route also will get changed. This is the main, this kind of, we can, this same IPSLA track, okay, instead of calling static routing, we don't need to call it any of routing also, but even if you configure the BGP also, with the BGP performance also, we can configure the IPSLA and we can monitor proactively in the routers. By using IPSLA, I have shown how to do that. Okay, even we can use the IPSLA, we can use it policy based routing also. That policy based routing we will discuss in upcoming sessions. Command IPSLA 10. The 10 in the sense the numeric anything you can give it. It's a number. Okay, it's like a 1 for 1, 2, 3, 4 like that we can give it. How many we can give? How many IPSLA we can configure? Let me show you guys. IPSLA. We can configure these many entries of IPSLA. These many entries of IPSLA. That is the purpose of that command. Then next I have used, we can use the many combinations. Now what I have used is ICMP. ICMP echo. What ICMP echo means, I need to keep on ping my that destination. Even you can give the more specific. Okay, from this destination I have to ping from the particular source. That also can be used. Why I am telling? Okay, here if I'm using the dual service provider, if you are pinging any public IPs, even the public IP will be reachable over the secondary also. Okay, if you want to specifically want to reach that destination over the private primary circuit, okay, primary source, that you have to, you can clearly mention it. IP, ICMP echo that IP, then source interface, source IP, all those things we can customize it. And then threshold. What is the threshold? Like a threshold is specifies how much time that event should happen. Okay, considering the particular SLA is down. Okay, uh, how much time I need to wait. Okay, like that. Okay, till what time I need to check. Frequency every 5 seconds. Here I have mentioned is every 5 seconds. Okay, every 5 seconds you check whether this IP is pinging or not. IP is pinging or not. Okay, how much time I have to wait? Okay, if it's a 5 times, it's a failed out. Okay, the threshold will comes 5 milliseconds. I have kept as a 5 milliseconds threshold here. Okay, 5 milliseconds, the frequency is not getting responded. Then immediately this SLA will go down. Okay, how the SLA will get tracked? Okay, I have used this command. I track 10. 10 also, the track number also we can configure like that only. Let me, how many tracks we can configure? Track. These 100 objects we can track it. Now I am tracking IPSLA. IPSLA, the track number 1 or 10, whatever you can give the number. After that, IPSLA I'm going to track, or which IPSLA? IPSLA 10 I'm going to track. Here one more command I have used it, IPSLA schedule. Okay, I'm going to schedule this IPSLA from when it has to start. Okay, IPSLA schedule. Okay, which IPSLA number? 10. Lifetime. Okay, forever, always it should be on. Okay, start time. No, immediately it start. Like that, I have given a traffic went here. Okay, this link was down, and then it is not able to float the traffic via this link. Still, this static route is getting a preferred. Okay, to rule out this problem, okay, we use this IPSLA scenario. It will track this path. If this path is goes down, traffic will start flow via like this. It will start getting flow like this. Now let me show the configuration again to you people. Show run section SLA. See here, IPSLA is configured. Okay, IPSLA schedule time forever already configured. Okay, now this you ignore it. Okay, for testing we have configured. I'll delete that. You can ignore it. Now let me show you show pipeline route. In this, I have primary path. I'm tracking it. Secondary, one more destination I'm tracking with this. In case my track goes down, it will choose the secondary path, my floating ground. It will choose it. Okay, the track I'm tracking, the my static route I'm tracking here. The same track can be used in multiple purpose. IPSLA track, even we called it in HSRP, and then the track can be called in the monitoring. All those things we can use it. We will see in upcoming session how we can configure a HSRP tracking. All those.